Let's talk about transfer learning in machine learning. Transfer learning is when you take what another model has learned about a similar domain and use that to train your new model from a predefined starting point. So let's take an example that's not in the context of machine learning, okay? Let's say you have two friends and you're trying to teach those friends how to skateboard. We'll say one friend has never skateboarded before, never snowboarded, never done any sort of similar activity, whereas another friend already knows how to surf, okay? Now, which of these friends do you think is going to pick up skateboarding faster? Probably the one that has some experience in a related domain, the one that's surfed before. In a sense, this is what transfer learning is in machine learning. It says, let's take what another model has already learned that's similar to what I'm trying to teach my model that's new and start from there when we do our training. I'm Joseph from RoboFlow, and today I'm going to take you through how you can use transfer learning in computer vision problems so that your object detection models can improve faster. Okay, so the example that I'm going to be working with today is a chess piece dataset, okay? So this dataset is available in its full form on public.roboflow.com. I'll put the link in the description. What the dataset is it's actually a series of about, this one has 189 images and 1,762 annotations across 12 classes, each of the chess pieces. And the goal of what we're trying to do is teach our model to do object detection of each of these individual chess pieces. Okay? Seems simple enough. So what we may want to do is we could start training totally from scratch, right? That means that we take a model where the model knows nothing. The weights are randomly initiated, and then those weights learn over time and try to get to the closest point possible. We could also start training from a different checkpoint. Now, that other checkpoint we would hope would be something that's somewhat similar. Remember my example with our friends. If we have one friend that we're trying to teach them both skateboarding, and we have a friend that has learned how to snowboard, maybe having that friend start would do much better in the lessons, whereas the friend that's never done anything in the related domain will take longer to learn. That's kind of what we want to do here. So I've actually gone ahead already, and with my data set of 189 images, I've generated two versions. Now, these versions don't have any augmentation. The only thing that's been done is their images have been resized to 416 by 416. Okay, so that's a 416 by 416 image, and same with this one. Okay, now when we kick off training, we're going to use RoboFlow, specifically RoboFlow Train, to kick off a training job. Now, we're going to do two different training jobs, okay, to demonstrate the power of transfer learning. In RoboFlow, when you click Use RoboFlow Train, you're basically saying, please, RoboFlow, train a model for me without me needing to write any code and give me the results of that model in the form of an API or a model I can use for future labeling or just to benchmark my existing performance. Now, you'll notice that I can do two things. I can train from scratch or I can start from a checkpoint. Train from scratch means don't use any pre-existing weights. That is, the weights will be randomly initiated, and the model will just learn the best that it can. Alternatively, I can start from a checkpoint. Now, logically, this checkpoint that I start from should be something that's a similar domain. Now, in RoboFlow, those things that I start from could be data sets that I already have on my account. So I actually already have a different trained model on my account of chess pieces from this example here, or I could start from a public model. And so the public models are models that are available on RoboFlow. So for example, the Common Objects in Context dataset, the COCO dataset, is where I could start my training from. Now I'm going to do two tests here. I'm going to do one model where I kick it off from the COCO dataset, and then I'm going to do another model where I kick it off completely from scratch. Okay? Now, if you're unfamiliar with the COCO dataset, it's also available on RoboFlow Public. And basically what it is a dataset of hundreds of thousands of images of objects in common contexts. Things like forks and spoons and persons and cars and dogs and microwaves and things like that. And so what I'm thinking here is if I start my training on the chess piece dataset, I'll try one from the COCO dataset to see if the common objects in context dataset approximates pretty well. And then I'll do another one completely from scratch. So I'm going to start training from the COCO dataset, and that goes ahead and that training job starts. And then on the other one, on V2, I'm going to start training completely from scratch. Okay, so those two have kicked off. Now, while those start to train, let's talk through the advantages of transfer learning. There's a few things that transfer learning does for us. One, it may and likely will improve the accuracy of our model. Because think about it, if we're saying that our model needs to learn, but it can start from what another model has learned in a similar space, then that model may optimize to learn the new domain even better. So, in other words, the first advantage is it may make for more accurate models. The second advantage is it actually likely will make our training time be faster. If we have a model that's starting from a predefined checkpoint of a similar domain, then we would think that the new model can learn, the rest of the way. Whereas the model that starts completely from scratch might take a little bit longer to optimize its loss function and understand our new domain more successfully. Again, think back to our example of teaching your friends a new skill. If a friend has experience in a similar domain, you would expect they can pick up the new skill faster than if they didn't. Now, transfer learning isn't totally a free lunch, mind you, and we'll talk more about that after we let these models train. So I'm going to let these models kick off and train. Now, while those models train, there is one other thing that I do want to walk through. So we describe transfer learning as being advantageous if we were starting from, maybe a related domain. But we could even do transfer learning on the same domain. So what do I mean by that? Let's say that with my chess pieces data set here, right now I only have 189 images. Now let's say that in theory, I had gone out and I'd collected and I labeled additional images. I actually have gone ahead and done that. So I'm going to go here and I'm going to click add more images. And then I have actually gone and I've created, I'm going to select my folder. And on my desktop here, I have an additional 100 images and annotations. So I'm going to select that folder and I'm going to click upload. Yep. And all of those images and their annotations are going to be processed here for my data set. And as I said, I have an additional 100 images. Now, why is this advantageous? Now, when I train again in the future, I don't want to start completely from scratch, right? If my model has learned what 189 images and 1,700 annotations look like, then I want to start from that point in time to add an additional 100 images. So these additional 100 images, I'm going to add them to my data set, and I'm going to add them all to my training set, in fact. So they'll all be added to my training set. And those are all going to be uploaded. Now, in theory, right, if I did this out in the wild and I've collected new images of the same domain, when I start training again, I don't want to throw out everything that my model learned before I collected new images. I want to start from the same point where I last left off. So, with all these new images added to our data set, we can go ahead and create a new version, and then we can kick off training again. But we'll kick off training from a checkpoint, and that checkpoint will be the ones that we just started. So I'm going to wait for these models to finish training and for this upload to finish, and then I'll come right back and I'll report the results of accuracy and the time that each of them took to train. So hold that thought. I'll be right back and we'll do a little movie magic. Okay, so our 100 new images finished uploading and both of our models finished training, which means we can compare the model results, V1 versus V2, and then we can also look and see if we start with our training checkpoint for the next 100 images, how that's going to change our model performance. So first and foremost, remember model V1, the dataset V1, was the one that we did the COCO weights pre-training checkpoint on. This is the one where we did transfer learning. V2 was the model where we started from scratch, where the weight started in a random position and learned only on this data set. So if we look at the V1 model results, we see that it does quite well. The map here is 98.5, the precision is 73.3, and the recall is 99.3. Now I'll put a link in the description for explaining what each of these metrics are in greater depth if that's of interest. Don't forget to like and subscribe to our channel as we post additional updates like that. But in general here, we're gonna be focusing on map. So 98.5% for the transfer learning model. Now, before I tune over to the V2, let me also tell you something about the transfer learning model. We kicked off both of these training jobs at the same time, but the transfer learning model finished 49 minutes before the model that started training from scratch. So the V1 model took about an hour to train, and the V2 model took about 2 hours to train from scratch. Okay, so we already know the transfer learning model was a little bit faster. Now its accuracy is quite good. How does that compare? The V2 model, we see the map is 97.9, precision 53.5, and recall 99.6. So the mean average precision of the transfer learning model is ever so slightly higher at 98.5. The precision is much higher at 73.3, and the recall is actually slightly lower, 0.03% lower, at 99.3. That could be attributed to noise, or it could be actually that it learned something very specific about our chess pieces. But in general here, we see that transfer learning has done a good job for us. Our model trained faster, and it's ever so slightly more accurate. Now, okay, I told you that I added 100 new images to this data set. You saw me upload them. So now we have 289 images, and that translates to having 289 images and 2,870 annotations. So over 1,000 more annotations. Now, I'm gonna actually go back to our data set here, and I'm gonna generate a version. I'm just gonna call this version V3. And this dataset version is gonna have the same pre-processing steps. So it's gonna be a 416 by 416 image that we pass to our model and no augmentation. So it's just gonna be the raw images that we're gonna pass to our model here. And so this V3 one, we're also gonna kick off a training job. So we'll click use RoboFlow train. And remember, we can train from scratch or we can start from a checkpoint, except this time, the checkpoint we can start from is we can grab a checkpoint from the chess pieces data set, and we can actually grab a model from one of our existing ones on our account. So I already have the, as I mentioned, that chess pieces data set on my account. So I'm gonna start training from that exact model, and I'm gonna kick off training. And while that kicks off, we're gonna go ahead here and use a little bit of movie magic and wait for that to finish while training is in progress. And we're gonna come back and update you with how long that took in comparison, and we'll see the metrics and results to see if there's any notable difference. Okay, so see you in a bit. The model finished training. Okay, so let's recap what we did. We first uploaded 189 images. We did training from a checkpoint on the Coco dataset. We also did training from scratch. Then we added 100 more images to our dataset, and we started training from a checkpoint on that same model. So our model didn't have to start from scratch. It could remember what it learned from those first 189 images and then apply that forward on our next 100 images. So that was V3. I need a little drum roll. The results, 98.9% map. So remember, V1 saw 98.5, V2 saw 97.9, that was training from scratch, and V3 saw 98.9% map. Now notice the precision is slightly lower, and the recall is a little bit higher. I mean, those numbers kind of depend on the thresholds that you use. I'll link in the description more about those metrics. But all in all, we've done it. We've successfully used transfer learning in computer vision. Please like and subscribe to our YouTube channel to get up-to-date updates about videos, tutorials, blogs, and new features in RoboFlow. And thanks so much for tuning in. Happy transfer learning.